Next, we're going to be learning about circles, angles of a circle, and we have a lot of vocabulary, a lot that we're going to be learning. I recommend lots of colors, markers, however many colors you can get, we're going to use them. And we're going to be using these notes a lot. So take good notes. I'm going to move kind of fast because we have a lot in this video. So if I go too fast, just pause it so that you can take your time writing stuff down. Okay, so we have some pictures or things that we're going to draw so that we can understand the vocabulary. You have some basic circle vocabulary drawn already that I expected that you would know. Center, radius, diameter, circumference. Remember, circumference is like the perimeter of a circle. So the first thing that I'm going to have you draw is actually sector. The second thing on the list. I think of sector as like a piece of pie. So that's the sector of the circle. So this right here. And it's like the whole thing. It's like the whole piece of pie. I'm not going to color it all in because I'm going to write some more things on there. So that's the sector, and it's the whole piece of pie. The next thing that we're going to label is called the intercepted arc, and that's this part right here. So the intercepted arc is like a portion of the circumference. It's like a little piece of that outside. Intercepted arc. All right, next on the list we have the central angle, which is an angle that is made with the center of the circle. So this is, I wrote really close to that, the central angle, an angle that is made using the center of the circle. Next, we have an inscribed angle. So this is an angle that is not made with the center of a circle, but it is made with the vertex still inside the circle. So the vertex is like the pointed part of the angle. All right, there is an inscribed. Inscribed angle. Next, we have a circumscribed angle. A circumscribed angle is an angle that is outside of the circle. So you have a vertex like this. That is outside. Circumscribed. That is a circumscribed angle. Next, we have two that I'm going to do together, a tangent line and point of tangency. So this part of the circumscribed angle and this part of the circumscribed angle are actually both considered tangent lines. I drew those in brown. I'm going to go ahead and draw this in purple, which might be hard to see since those colors kind of look similar on camera. I guess you can kind of see that. So this right here is the tangent line. The point where the tangent line and the circle come together, that single point where they meet, is called the point of tangency. So tangent line and point of tangency were both in purple. Next, we have what is called a secant line. Doing that in blue. This is a secant line. Secant line goes through the circle, so a secant line is going to touch the circle in two spots. A tangent line only touches the circle in one spot. And then next on the list we have a chord. A chord. So these are all important words for the unit. These are words that are going to show up in problems. I'm going to throw them out there. I'm going to use them as we learn, so they're going to be important to be labeled clearly. This is not a unit where you put the notes in your binder and never look at them again. This is a unit where you're going to have your notes out every day as you do your practice. So make sure you're taking good notes right now, that they're clear, legible, that they make sense, because we are going to be using them a lot. All right, circle conjecture number 1. Today we're going to do 1 through 5, not necessarily all in this video, but that's what our first lesson is going to be focused on. So circle conjecture number 1 says, if an angle is a central angle, so if you start with the center of the circle and you make an angle, we're going to label this as x degrees, then the measure of the angle is equal to the measure of the intercepted arc. So this is the central angle, the intercepted arc is this part right here, and we're just going to say, oh, central angle, intercepted arc, they are the exact same measurement. That's going to be fun for us because it's pretty common sense. It just seems right. All right, so here we have some notation you probably haven't seen before. They are asking us in this problem to find the measure of arc CFD. And this brings to light something we probably haven't considered before, which is what is a major arc, what is a minor arc. So a major arc, I just spelled arc wrong. A major arc is an arc that is more than 180 degrees. And you can tell that it's more than 180 degrees because it uses 3 letters. So it's more than half of the circle because half of the circle would be made up of 180 degrees exactly. A full circle is 360, half of the circle is 180 degrees. A minor arc is less than 180 degrees and uses 2 letters. All right, so that's just some notation for you, okay? So when they talk about CFD, it kind of tells you which direction to go around the circle. Should we go CF this way? Or should we go CF this way? Well, the D helps you to clear it up. CFD tells you to go that way. If you went CFD this way, then you'd be going all the way around the circle and then some, and that doesn't really make sense. So I'm going to go from C to F, and then keep going. So when they said find the measure of arc CFD, they want to know how many degrees is this whole arc all the way around, right? Now, if we look, we have some clues already. This central angle is 135 degrees, and so this arc right here is 135 degrees. This central angle is 81 degrees, this arc is 81 degrees. And that's where our information stops. So one part about these problems is that they typically say this in the directions, but I didn't put it in the directions for examples. But if you have any line that appears to be a diameter, typically in the problems they'll say, if it looks like it's a diameter, then it is. So this looks like a diameter, which means it does cut the circle in half. That means that this would add up to 180 degrees because half of a circle is 180 degrees always. So what I can do is I can cover that up and I can say, oh, if this is 135, then this angle should add up to 180. So I can just take my calculator and do 180 minus 135. So that means that this central angle is 45, which means that that arc is also 45. I can do the same thing right here. If that is 135, then this should add up to 180 because that's half of a circle. So 45, 45. And now I have all of these arcs labeled so that I can figure out what that whole major arc is, arc CFD. So 45, 135, 45, and 81. So that arc is 306 degrees. All right, for the next one. So this is 140. These right here, these are called vertical angles. They're actually the same. Anytime you have something across from each other like that, those are the same. Sometimes it helps you to label those and write that they're the same. Sometimes it doesn't really help you. In this case, it doesn't really give us much, but I always like to label everything in the picture that I can. So 40 and 40, I can do the same thing again where I can say, okay, that's half the circle. So if that is 140, then this must add to that to equal 180. It must be half of a circle. So that's 40. That means that 140, that means that this must be 40. Now, these two have to be exactly the same because this is a central angle, this is the intercepted arc. So that means that this equals 40 degrees. Now, all they're asking me to do in the problem is solve for x. So I can go ahead and do that. 6x minus 8 equals 40. Add 8. 6x equals 48. Divide by 6. X equals 8. We'll go ahead and leave example 3 for tomorrow. All right, next, for circle conjecture 2. If an angle is inscribed in a circle, so we're going to do this two different ways, just because there's kind of two different ways of thinking of it. So you can draw the same angle, that's fine. So here's your inscribed angle. If an angle is inscribed in a circle, then the measure of the angle is equal to half the measure of the intercepted arc. Okay, so one way to think of this is you could say, okay, the arc is x degrees, and so the angle is 1/2 of x degrees. That's one way to think of it. Or you could say, all right, if the angle is x degrees, then the arc is double that. So two different ways of thinking of it based on the information that you're given. Both of them work. It just kind of depends how your brain works, what the problem gives you, okay? So either think of it this way, they gave me the arc, I take half of it, that's the angle, or they gave me the angle, I double it, that's the arc. Either way you think of it is fine, okay? So in this problem, they said the arc is 140 degrees, what's the angle? Well, I'm just going to take it, I'm going to cut it in half. So it's going to be 70 degrees. Okay? Here, so I'm going to say, let's go this way and say, cut it in half. Okay? We'll say half it. Okay. This one, they gave me the angle, 34 degrees. We're going to go out that way. We're going to double it. I don't know why I'm using an accent. Double it. So that's going to make this 68 degrees. Okay, so if the angle is 34 degrees, the measure of arc x is 68 degrees. All right, in the next example, they have a measure of the minor arc SP, that's right here, SP. So they have the angle is 27. We're going to go ahead and double that, and we're going to get 54. Here they have the arc is 118. We're going to cut that in half. 118, cut it in half. You get 59. So angle PRU is 59 degrees. All right, I'm going to leave that one for when we do our notes in class. Circle conjecture number 3. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. All right, here's where we get our colors out. This is where it's going to blow your mind a little bit. Okay. Start with one color. It doesn't matter what color you use. I want you guys to draw approximately the same angle as me, okay? So we're going to start with green. I'm going to just draw this angle right here. Okay? That's the angle. All right? And I'm going to take pink, and I'm going to draw the intercepted arc with pink. So here is my intercepted arc. Okay. Now I'm going to take a different color, blue, and I'm going to draw a different angle right here. But see how I'm still making it go with pink. So what they're saying is that the green angle right here, green angle, blue angle, since they both have that intercepted arc of pink, those two angles are congruent. In fact, I could take another color. I can go over here and I can say, whoop, this and this. Let me draw another inscribed angle. Yep, if I were to measure it, that one is congruent to these as well. All three of those angles, if I were to measure them, they're all congruent because they have the same intercepted arc. Okay, so circle conjecture number 3 is where things start to get weird. It's also where I start to use my colored markers more often. So let's go ahead and look at one more example in the video, and then we're going to be done with the video. This is where I get my markers out. So what I like to do is whenever I have something like this, where I can tell that we're talking about inscribed angles and intercepted arcs, is I like to start with the vertex of the inscribed angle. So there's angle 1. Inscribed angle 1, I'm going to follow it out, and then I'm going to trace the inscribed angle that goes with it. I'm going to trace the intercepted arc, the intercepted arc that goes with it. So 116 means that the angle for that inscribed angle is 58. 116 cut in half, that's 58. So measure of angle 1 is 58. All right, now I'm going to go to angle 2. I'm going to pick a new color. Go ahead and do purple. Again, I'm going to start with the vertex. Again, I'm going to trace the vertex out to the edge. And then I'm going to trace from one edge, I'm just going to connect those. And you can see that the purple and the red traced the same arc. So that means if they traced the same arc, then those two angle measurements must be the same because the arc went with the same angle. So 116, cut it in half, we get 58. So since two inscribed angles intercepted the same arc, those two angles were congruent. That's what circle conjecture 3 tells us. It's a little bit mind-blowing, but it's true. All right, the rest of the notes we're going to leave for class, so don't feel like you have to do any more of those notes at home. Sorry it was so long.